So welcome to data structures and algorithms by using Java. So in yesterday's class, what is the course content I explained very clearly. Like around we have 20 modules are there. Every module we are going to see in detail one by one. Okay, all these modules I demonstrated very clearly, like algorithms. Analysis of algorithms means what? What are the algorithms that we are going to see? And what about the data structures? What are all the data structures we are going to cover? All these things I demonstrated. Sir, even what is mean by recursion? As a topic, sir, we started with recursion and applications. So it is a demo session as well as I started the regular content, sir. So that means the content which I am going to demonstrate now itself is the syllabus. Itself is the syllabus. So what is mean by recursion and what are the various applications of recursion? That topic I started. And at the very beginning, I explained a simple Java program, how to create a simple Java program, how to compile that program and how to execute. That part I demonstrated. After that, sir, how to create a method. Okay, from your main method, how we can able to call that method? How we can able to call that method? Sir, whenever you are calling another method, internally there is one data structure that will be created called a stack. I told very clearly, internally it will create one special data structure called as what? Stack. How to create that stack? So how that manipulations is going to be performed, I explained very clearly by taking some examples. So generally what will happen if you take this second example, generally what will happen whenever you are executing a Java program, internally JVM is going to create one stack. JVM is going to create one stack. Inside this stack, so stack entries will be there. Inside this stack, stack entries will be there. One by one method calls will be stored here. So first of all, by default, we know the program execution starts from main. Main is going to call some other method, let it be M1. That M1 method is going to call some other method called M2. That M2 is going to call some other method called M3. So M3 is independent. It is not going to call any other method. Like that it will be there. And once if M3 execution completed, it will delete the instructions. It will delete that entry and it will come to the most recent method call, which is nothing but M2. Then it will complete its execution and it will come back to the next most recent method call, which is nothing but M1. Like that, so after execution of remaining instructions in main method, it is going to terminate. This is nothing but the default structure what it is going to follow. This is nothing but the default structure what it is going to follow. I hope everyone clear with this concept. In yesterday's class, I explained this concept very clearly. Sir, everyone feeling comfortable up to this, please confirm.
Yes, sir, comfortable.
Sir, what about remaining students? Please respond. Right. Sir, after this, so we have seen some definitions also. So what is a definition? Sir, a method can call another method. We know that very well. A method is going to call another method. Next, sir, once if you are calling another method, you can able to call the same method also, right? Yes, a method can call same method also. There is no problem at all. Suppose if a method is calling the same method again and again and again and again, internally, what will happen? Sir, nothing. Just it is keep on going to store that stack entries. It is keep on going to store that stack entries. At one point, what will happen? At one point, what will happen? Sir, recursion is going to occupy the total stack. That is total stack capacity is going to be filled. Sir, in such cases, what will happen? Is it possible? Okay, is it possible to call continuously? No, because every Java virtual machine is having a limited stack size. If that stack size is expanded, then immediately you can't accommodate, sir. You can't accommodate. In such cases, what will happen? Recursion is going to be wastage. At last, you will get one error saying stack overflow. This process is called as recursion. How to avoid that stack overflow error? That is our today's concept. Okay, that is our today's concept. So now by seeing the definition, recursion is a process of calling. Recursion is a process of calling same method again and again. Recursion is a process of calling same method again and again. The method which is invoked in this process. Sir, which method is invoked in this? That method is called as recursive method. Okay, that method is called as what? Recursive method. And that process is called as what? Recursion. Like that we have. Okay, that method is called as what? Recursive method. And that process is called as what? Recursion. So these are the various terms that I explained in our previous session. Sir, if you are clear with this, then today the main topic I am going to demonstrate. Up to this, do you have any questions?
Sir, what will be the size of the stack? Because we are getting stack overflow error now. What is the
That will be depending on the virtual memory that your system is going to give while installing the Java software. At the time of installing the Java software, how much memory it is going to give based on that.
So that means our laptop will give memory from RAM.
Yes, sir. Suppose if your RAM capacity is some assume that 1 GB, then what will happen? For stack, it is going to give some 50 MB like that. So it will utilize that. If it is going beyond the limit, it won't provide support. Suppose if your RAM capacity is 2 GB, it may provide 100 MB. That depends on the RAM capacity. See, that's why always the processor speed must be very high. So if you want to execute the enterprise applications, all these things. The reason for that is nothing but what? More data is coming, more recursive calls is going to be happen. Then it should be able to control that. Got it?
Got it.
Yeah. But here there is one small note point is there. What is that note is recursion. Okay. Sir, recursion always leads to infinite execution. Correct? It always leads to infinite execution, sir. That is, sir, it never ending process. It is a never ending process. It won't stop. But sir, I want to make it stop. Is it possible or not possible? Yes. Sir, if we want to stop these recursive calls, then we have to write an explicit condition. We have to write one explicit condition. Sir, that special condition is called as nothing but what? Base condition. What is that special condition? It is called as base condition. So if you want to stop the recursion, we have to write one explicit condition. So that explicit condition is called as what? Base condition. Comfortable up to this?
Yes, sir.
Now, sir, I will show you one example program which is going to give full-fledged clarity. Now, have a look once. Sir, I have this method. Let us call shortcut M. Now here I am taking M. So here also I am taking M. Now, what will happen if I am executing this Java program? Have a look once. Now you can see it is keep on executing, right? It is keep on executing. So it is a never ending process. Sir, I want to make it as a stop. Then what will happen? Here I am going to give 4. So what is the meaning of this? I want to print this hello message. How many times? Only 4 times. I want to print this hello message. How many times? Only 4 times. Then this method is taking some parameter, right? Here also within bracket you have to take n. Now here I am going to call for n minus 1. Now see what will happen. Sir, first a stack will be created. Okay, which is calling main method. I won't write main method here. Okay, if you want to avoid confusion, let us write. Sir, main method is calling some other method. What is that method? M of 4. Then M of 4 is calling some other method M of 3. Sir, M of 3 is calling some other method M of 2. Sir, M of 2 is calling another method called M of 1. Now, sir, how many times I want to print this hello? 4 times. First time, sorry, second time, third time, fourth time. Completed, right? So whenever you are getting M of 0, sir, I want to stop the process here. Here I want to stop the process. So when n is equal to 0, I want to write one explicit condition. Sir, if you are clear with the logic, then we can write code for that. Any questions, means please ask.
So sir, we need to write a condition. If 0 comes, we don't have to execute.
If 0 came means we have to stop. Got it? See, n value we are keep on reducing. Whenever n becomes 0, we have to stop. Understood?
Understood.
Yeah. Now let me write that in the form of a program. 1 second. Right. Now we are going to write a condition. Now see, what is that condition? If the value of n is equal to 0 means, sir, what I am going to write? Return. Return means what? It will come out. Okay, if n is equal to 0, what is the meaning? Just I am going to returning out. Just I am going to returning out. Like that we have. Sir, understood now this question? I mean this particular condition. Clear?
Sir, can we write here break instead of return?
No, you know very well about Java, right? In Java, so when you have to use break, when there is a loop or when there is a switch condition, then only you have to use break. Clear?
Clear, sir.
It
Got
is
it.
a
Thanks.
transfer step. Now see what will happen. Let us execute and check. So is it really taking that control? Sir, hello. How many times this hello got printed? 4 times. Understood, sir? Everyone? Any questions up to this? Clear?
Yes, sir. Clear. Sir, the return just telling don't do anything. That's it, right, sir?
Return is telling just come out from the function. That's all.
Okay.
Okay. So everyone clear? I will show you with one more diagram. Okay. Now, sir, observe carefully. What is that another diagram that I want to take is, let me put this. Have a look once. Sir, initially we called M of 4. Sir, inside m of 4 function, there are two main activities are there. What is the first activity? Sir, it is printing a message called hello. It is printing a message called hello. After that, we are calling the same method by passing 4 minus 1, that is nothing but 3. Are you clear with these two instructions, how it is going to run?
Yes, sir.
Now, sir, this m of 3, again it is going to print, sir, hello, followed by m of 3 minus 1, 2. Sir, same thing for m of 2, it is going to print hello, followed by m of 1. Sir, it is going to print hello, followed by m of 0. Am I right, friends? Whenever 0 is coming, it is going to stop the process. Now, you can see what is output of the program. Sir, hello, first time. Sir, second time. Third time. Fourth time. This is called as state space tree, SST. This is called as stack diagram. So, if you want to understand recursion very clearly, both the concepts must be required. I mean, the code you have to represent in stack as well as in this diagrammatic format. Then only you can understand well. Clear?
Clear, sir.
Sir, what about others? There is no response from other students. Right. Now, have a look, friends. Just let me copy paste this diagram for your reference purpose. I mean, code already copied, right? Okay, no issues. Now, observe carefully. The point which I am going to write now is very, very important. See, there are different cases. There are different cases are existed in recursion. So there are different cases. What are those cases? Sir, I am writing case 1. What is case 1 is based on method calls. Okay, based on method calls. Sir, we have two types. We have two types of recursion. Sir, based on method calls. Sir, what is the meaning of this? First one is nothing but, sir, finite recursion. Second one is infinite recursion based on the number of method calls. Sir, finite recursion means what? It should stop. It should stop at a certain. It should stop at a certain point. It should stop at certain point. Sir, infinite recursion means what? It never stops. It is keep on existing until the stack is full. Until the stack is full, it is keep on executing. That is called as what? Infinite recursion. It never stops. It keep on executing. It never stops. That is called as what? Infinite recursion. So I think we have already demonstrated this. No need to take any example. Clear, friends?
Yes, sir.
Now, so what is a case 2 here is, what is a case 2 here is based on, okay, based on number of methods. Based on number of methods, sir, we have two types of recursions are there. So based on number of methods, we have two types of recursions are there. First one is direct recursion. Second one is indirect recursion. First one is direct recursion. Second one is indirect recursion. Sir, what is mean by direct recursion? Have a look once. Let me give overall example. I don't want to go for any programming. Sir, direct recursion means, suppose if you have any method here, inside this, I have some instructions to execute. Again, I am calling the same method. I have some instructions to execute. Again, I am calling the same method. This is called as what? Direct recursion. This is called as what? Direct recursion. Directly we are calling. Okay. Sir, everyone clear? Direct recursion means what?
Sir, in
Clear?
this direct recursion only, na, both infinite and finite recursion will come.
Yes, yes. But in indirect also it will happen. But that is different case. Direct recursion means what? Only one method will be there. That method is keep on calling another method. Let me explain indirect recursion, then you will get clarity. Indirect recursion means it is also a recursion. I have a method m1 will be there. So inside that, I'm going to write some instructions here. After that, I'm going to call second method m2. And in second method, what is happening? Sir, in second method, we have some group of statements are there. After that, we are calling the same method. Got it, sir? Sir, now you understood the difference.
Yes, sir.
Any questions, friends? So now, another type of recursion. Sir, based on the position also, we have different types of there. Case 3, this is very, very important. Case 3. So based on the position, based on the position of recursion call, sir, we have two types. We have two types of recursions are there. Sir, based on what? Based on the position. Based on the position, we have two types of recursions are there. Sir, what is the first one? The first one is called as what? Tail recursion. Tail recursion. Sir, what about the second one? Second one is non-tail recursion. Based on the position, we have two types are there. One is a tail recursion, another one is non-tail recursion. Sir, what is mean by tail recursion? What is mean by non-tail recursion? Let me give a clear example. Then only you can understand well. Later, I will give the definition. Sir, what is mean by tail recursion? Tail recursion. See, after recursion call, you can see here, this is a recursion call, right? Sir, for better understanding, what I will do is, after printing this hello, three dots followed by, I will try to print n. I will try to print n. Now observe, sir, after recursion call, which is a recursive call, this eighth line is nothing but what? Recursive call. Sir, after recursive call, are we taking any statement? No, sir. Then it is called as what? Tail recursion. Sir, after recursive call, if we are trying to take, okay, if we are so trying, if you are trying to take in, if we are not, okay, if we are not taking any method calls or any Java state, if you are not taking any statement, then such type of recursive, okay, such a type of recursive call, such a type of recursion, such a type of recursion is called as tail recursion. Tail recursion, that means after recursive call, we are not taking any step. Sir, what is the expected output for this program? Let me cross check. Sir, what output we are getting? Are you seeing hello 4, hello 3, hello 2, like that it is coming? This is called as what kind of recursion it is? Tail recursion. Okay, sir, what is mean by non-tail recursion? Exactly opposite for this. What is mean by non-tail recursion? Sir, after recursive call, okay, after recursive call, if we are taking any statement, then such a type of recursion is called as what? Non-tail recursion. Such a type of recursion is called as what? Non-tail recursion. Sir, here I am taking this SOP after this. Now, immediately you may have a doubt. when it will be executed. So don't worry, as of now, this is nothing but what? Non-tail. This is nothing but what? Non-tail recursion. But when it is going to be called, I will demonstrate. Sir, are you clear up to this?
Clear, sir.
Now have a look once how it is going to work. Sir, first we are calling m of 4. It is having two statements. What is the first statement? It is not SOP. It is not SOP. It is calling another method by taking n minus 1. That is nothing but 3. Now, this one is again calling m of 2. Sir, this one is again calling m of 1. This one is again calling m of 0. Like that it is there. Sir, up to this clear? This one got terminated. This one got terminated. Now, sir, while coming back, this instruction is not executed, right? While coming back, this instruction is not executed, right? That will execute now. Sir, it will print hello 1. This will print hello 2. This will print hello 3 in reverse order. This will print hello 4. Like that it is going to take. Observe carefully. Sir, is it printing hello 1? Yes. Is it printing hello 2? Yes. Is it printing hello 3? Yes. Is it printing hello 4? Yes. Like that it is going to print in reverse order. Hope everyone understood the scenario. Any questions?
Sir, I have a doubt. Where will this value of n be stored?
In the stack only, sir.
In the stack, we are storing only the method calls, right? Along with that,
No.
we will store the...
Along with that, it will store the data also. Okay.
Sir, if it is coming out of this void method by writing return, then how this each line is executing, sir?
That is the scenario, sir. That's why you have to understand recursion in detail. See, recursion means what? Here we are keep on calling at 7th line. Am I right? From 7th line, the control will go to the 3rd line. Again, after executing all these things, from 7th line, it will go there. Again, like this. Sir, when 8th line will get a chance? So, in the stack, first, m of 4 is there. Then m of 3 is there. That is very, very important. That is the internal story of stack. M of 2. So, then m of 1 and then m of 0. Till now, what is the direction of the flow? From here to here, and from here to here, and from here to here, and from here to here. Am I right, friends?
Yes, sir.
And I told one point. Sir, once if its execution completed, it will come back. It will verify is there any pending instructions is there or not. That's what happened even in our previous examples. Do you remember? Here, sir, after calling method 1, after executing method 1, then only this line will get a chance. In the same style, this line will get a chance when it is coming back. At the time, what is the value of I? 1. Next, completed, come back. Sir, value of n 2, hello 2, come back. Hello 3, come back. Hello 4, come back and report. When you are going like this, whatever statements you have taken, it will become tail. Whenever you are coming in these, it will become what? Non-tail. Understood, everyone? Please confirm. Clear up.
Sir, what are the unexecuted statements that are there in back, like in non-tailing, it will execute remaining statements?
Yes. Non-tail recursion, another name is nothing but backtracking, sir. Now you got the point? Non-tail recursion, another name is nothing but backtracking.
Yes, sir. In backtracking, it is not executing which statement are already executed. It is executing
Yes.
only non-executed statements.
Yes, exactly. Understood, everyone?
So in which scenarios we should use daily precaution and which we should use manual?
Both we are going to use, sir. The total application is going to work on these two only. For example, if you take best example, Sudoku is there. Sudoku is there. Sir, I want to place one digit here. For example, assume I have taken 4 here. Then next you should not take 4. You need to take some other number. Let us consider I tried with 3. So I tried with 4. All the digits I tried from 1 to 9. But no one is probably it is adding. Then what will happen? Come back. Previously you have taken 4, right? Now try with 5, sir. Sir, understood the scenario? Yes, multiple statements also we can take. In the tree and all, we are going to use these kind of structures only. Slowly you will get, once if I start applications, slowly you will get the concept. Okay, now?
Sir, are we going to use this concept anywhere in data structures, like in other concepts?
Sir, believe me, 70 to 80% of data structures is purely depending on this only. Okay. That's why I will give main importance for recursion. Almost some 20 to 30 applications I am going to cover only on recursion. Step by step. 15 minutes, one problem. Every day, 4 problems, 5 problems. First 1 week, we are going to spend only on recursion. Okay.
So right now, basic doubt. Whatever that we are doing here can be done by using a loop also. Right? Then why do we need recursion?
Very good question, sir. Very good question. See, I have one program is there. I will show you that program. Okay. I will show you that program. Then you will get clarity. So I have a small program is there. So what is this program is? Sir, it is generating all the possible combinations. If you are giving the input as ABC, all possible combinations it should generate. Means what? ABC, ACB, BAC, BCA, like that. Sir, you understood the problem statement, right? Everyone? So I can solve this by using loop also. But I am using recursion here. You can see it is a recursive method. Keep on calling. If I use recursion for small set of data, you can work. Suppose if my input is Prakash Babu or Prakash, then what will happen? More number of combinations you will get, right? In such cases, have you observed how many combinations I got? If you want, let me count. So these many combinations, is it possible to write by using a loop? Definitely it is not possible. These many combinations, it is not possible. So you can see how many values it is taking. Sir, almost, if you want, how many characters are there in this input? How many characters are there in this input? 3 plus 3, 6 plus 1, 7, 7, 7. So 7. 1 second, 1 second. Sir, 7 combinations. So import math. So math dot factorial of 7. So what is 7 factorial? 5040. These many strings you will get. Is it possible to write a loop for that? No. You have to use only recursion for solving such type of complex problems. For small problems, there won't be much different. Even when compared with the loop, recursion is very dangerous thing. But based on the problem statement, you have to use. So there are so many dependence topics are there. When the problem is big, we have to divide that problem into small problems, solve that problems recursively, finally combine the solution. Divide and conquer. So like there are different approaches. Don't worry. All these things we are going to cover with multiple examples. Step by step, I will explain. Got it, sir? Yeah. Any other questions? Feel free to ask your questions.
So, sir, that means the alternative to recursion is arrays, right? Like for
No,
loops,
no.
loops.
Yeah, loops, yes. But up to certain level, it will provide support. See, best example, in villages, there are some maestries will be there. In Telugu, they are going to use the word called maestri. So what is the job of their person? The job is nothing but what? Sir, they can construct small houses with 1 or 2 floors. Now assume, so I'm staying in village. I will appoint one contractor who is there in Bangalore. Now I'm bringing and I'm giving some amount and I'm asking him to construct a 2 floors building in my village. It is meaningless operation. Why? Sir, recruiting a higher level position person to construct a small amount of building. You can construct with local people. Now, getting these local people and appointing in Bangalore to construct a 20-floor building. This person knowledge may not sufficient there. He may not get that much confident, that much resources. So both are different. One person cannot replace with another person. But when the problem size is very big, you have to go for recursion. When the problem size is very small, you can use loops. But since I am demonstrating recursion as a teacher, I need to explain how recursion is going to work. So now in my hand, that Bangalore contract person is there. I will start constructing first a small wall, then 4 walls. Okay, then 1 floor, then 2nd floor. Like that, slowly I will make you to understand. Got it? Any other queries? Any other queries? Please confirm.
Clear, sir.
So that's all about today's session. From tomorrow, we are going to start developing the applications one by one, step by step. I will start exploring from tomorrow. Okay, clear, friends?
Clear, sir.
Yeah, right, sir. Thank you.